All right, so I was asked to take a look at a couple of these ones from the exponential equations worksheet. And so we're going to be taking a look at number 7 here and number 11. I'm not going to steal away the opportunity for you guys to work through these particular ones. So what I'm going to do is I'm going to do ones that are just like it. So starting off with number 7, I'm just going to change it just a little bit. So that way, there we go. And so the idea here is that whenever we have something with the same base, one of the ways that we could go about this is to put them so that way the e is going to move up to the numerator. And so whenever you switch the side of the fraction, whether it's numerator to denominator or denominator to numerator, either way, what's going to end up happening is you're going to change the sign of the exponent, meaning that we're going to go from 1 over e to the 7th to e to the negative 7th. And the same idea would work on the other problem as well. And then what happens is now both of them have the same base. And if this is the case and the two are equal, that means that the exponents must be equal. And so we could just say x plus 3 equals negative 7. Or if you want to be really fancy about it, you take the natural log of both sides, and which would then leave us with the exponent becomes our answer for both of them. And then we just go through and solve the equation like so. Same idea for the other one. It works the same way. It's just a little bit different, just different numbers, but same steps. All right, so number 12 here, the idea, or I'm sorry, number 11. So you got this formula that models the population of a particular city. And so this could be anywhere, it doesn't matter what. And T years after 1998. So that's an important thing to remember. 1998 part. When will the population of the city reach 317,000? So 317 is the amount that we're going to get to, and we're going to use that here with the A. So you'd end up putting the 317 there and solving for T. So I'm going to do a different one, a little bit different. And the idea then is, let's say it's 135 e to the 0.045 t. So a little bit faster growth rate, and we're going to reach 200,000. And t, we'll still go with t, is years after 1998. And that's an important thing that we got to do is we got to look at what these things mean, what do the variables mean. But the 200 is going to be your A, going to be your amount. So 200 equals 135 e to the 0.045 t. Now I'm going to go through this and do all the algebra before we stick it into the calculator and try to figure out what that works. I think that works out the best, and that's just a good principle to follow, especially if you're going to go on and take physics or chemistry or anything like that. It's always a good idea with those problems to wait till the very end to put it onto a calculator. That way you don't round incorrectly at some point. Or one of the things about rounding is as you go along, that if you make little adjustments along the way, then if you keep adjusting in the same direction, you're going to pull farther and farther away from the actual correct answer. And so if we wait to the very end to round, it'll actually, that's going to be the most accurate way possible. Just imagine if you're going to the moon and you kept making little bits of right turns, eventually you just miss the moon altogether. So after dividing by the 135, because that's multiplying there, then we're going to deal with the exponent. So we're going to take the natural log of both sides. And so now we have the natural log of the quantity, 200 over 135. And natural log and E are inverses, meaning that the input becomes our output, so 0.045 t. And then the last thing we need to do is divide by the 0.045, 0.045. And so we'd end up with that. And so now with this, let's just use a calculator here on the computer real quick. So we'd have 200 divided by 135 gives us that. And then we're going to take the natural log of that, and we're going to divide that by 0.045, which gives us t equals 8.734. All right. In calculus, we're going to be doing 3 decimal places all the time. So it's not like physics or chemistry where you have significant figures. We're just doing 3 decimal places every single time. Now, of course, it actually means at least 3. So some people really want to they'll keep going. They'll keep writing it all out until they actually round down. As long as you go past 3, you're okay. So this means T is that, but that's not our answer because we want to know what year. So this is going to be 8.734. We're going to have to add that to our years, because remember, this is years after 1998. So we're going to add that together. And so then we'd end up with 2006.734. And so in this case, what would end up happening is that would end up so we have 8 full years after 1998, so 2006.734. And so either, this would happen if 0 is, January, then this would happen in 2006. So it would be in 2006 is most likely how that would read. So there you go. And I hope that helps. And let's get this and we'll stop our